Hello and welcome back to Ganesh Institute channel. So in today's video, what we are going to discuss is about the rank of the matrix. How we can calculate a rank of the matrix when something called linear mapping is given to us. So let's discuss what this terminology means and how do we calculate rank. Let's take an example for this. So here, it seems complicated, right? So here a question is given to you that there is a matrix T, or you can say it is ranging from R square to R square. R is the set of real number, and this is a linear map. So what is linear map? You can say linear mapping, linear transformation, vector space homomorphism. All these types, all these names are for a mapping which is from one set to another. So what we are doing, let's say if you are taking any number from here, let's say there are two values. So if you are having x as 2, you are getting y as 1 here. Okay, so this is sort of mapping. You show it with the help of arrow diagram. Okay, so you will write it like 2 comma 1, right? Now if you have got r square, it is for r to r, mapping from real number to real. Now if you have got r square to r square, so it will be something like 2 comma 3 to 4 comma 5. So for every value of 2 you will get 4, for every value of 3 you will get 5. So if you are presenting it in the form of linear mapping, so what does it mean is you are having a mapping between two vector spaces, and you can thereafter perform some operations like vector addition, scalar multiplication and all. You can write it as, so this is your 2 comma 3, you can write it as in the form of linear mapping like 4x plus 5y, something like this. So I hope you have got an idea about what does linear mapping mean. We will discuss it further on with the help of question. So what you have got is, if you have value of t as 2 comma 1, then you are getting resultant as 5 7, and for t comma 1 2 it is 3 by 3. This is 3 comma 3, this is given to you. Now you need to find out a matrix A, and this is corresponding to T with respect to standard basis. I have already made one video based on base. You can check that out. Just for your information and recapitulation, let me tell you about bases also. So basically, let's say you have a matrix, okay, 1, 2, 3, 4, any matrix of any order, okay. Now you reduce it how? Maybe through row reduction method or column reduction method, Gauss elimination method, any sort of method you can use in order to reduce it. Maybe you will make this as 0, this as 0, and make it an identity matrix, right? So rank of a matrix is like having all the rows as non-zero numbers. All those rows which are having non-zero number, those will be considered as rank. Just like you can see here, these are having four numbers, and for all of those four are non-zero, so the rank of a matrix is two rows. That means rank is 2. Okay, so rank is something, when you have to find out a rank, so rank is the dimension of this row space. Okay, dimension of row space. How does row look like? So so what you do, you find out the number of vectors. And how do you find out the number of vectors? By reducing your matrix. And that reduced form is called base. Okay, I hope you got this terminology right. Okay, now let's move on to the question further on. So you have to find out the rank of that matrix, but for that you need to first find out the matrix itself, right? You don't know even the matrix, you don't know. So what we have got is, we have these linear mapping. So T 2 comma 1 as 5 7, and another linear mapping as T 1 2 3 3, right? So what does it mean? You have some basis. So here this value after reduction is giving you this. Okay, So 2 comma 1 and 1 comma 2 is a basis. Okay, let's say this is P and this is a set of bases. This is basis. Basis of what? Because this mapping is going from R square to R square. So this is the basis of R square. And the resultant which you are getting from your second set, that is, let's say P1, what you are getting, 5, 7 and 3, 3. This is a subset because you are getting the resultant. It is dependent on these two bases. So this is a subset or can be equal to R square, right? Both of the things you are taking from R square to R square, correct? So these two things you are having. Now what we have to do is to form a matrix which is A and then need to find out the value of rank A, correct? So let us say in order to find out the matrix, we need to find out some of the numbers. So let's say we have AB from this particular set. If this AB belongs to R square, then this means AB should also belong to R, right? So if I write this in the linear mapping form, what it will be providing us is AB is equals to this form. X of what are the bases we are having? This one I'm making from the bases, okay, from R square. So this one and this one. So x into 2 comma 1 plus y into 1 comma 2, right? Where what are xy? Xy also belongs to R because ultimately this is belonging to R. So whatever we are having will belong to R if we are expanding this, correct? So if you expand this form, this is like vector space. So position vector you can assume. How you'll expand it? So here the first part A will be equal to 2x plus y, correct? So let me take up this pen. So A will be equal to 2x plus y, first part of each. And then what will be B? B will be x times 1x plus 2y, correct? Now find out the values of x and y from here. So let's take another slide. Here you can, what we have got is A as 2x plus y and B as x plus 2y. Now we have to solve it. How we can solve it? By elimination or anything. Let's say if I multiply this with 2, I'll get 2x plus 2 to the 4y and 2b here, correct? If I subtract them, this will be reduced minus 3y, a minus 2b, correct? So y will be minus 3, will go like this. So sign will be interchanged. So y we have got 2b minus a by 3, correct? Now for x, if you put y here, x plus 2y is what? 2b minus a by 3. So that means x plus 2 to the 4b minus 2a by 3. Then LCM, this is 3x plus 4b minus 2a. Here is b. It will be cross multiplied. 3b is equals to 3x plus 4b minus 2a. And hence, if you take this, keep this 3x here only and take these two terms onto the other side, 3b minus 4b plus 2a, right? So 3x is 2a minus b, so x is 2a minus b by 3. So now you have got x and y, which you have assumed that xy belongs to R, correct? Now if you substitute this into the equation where we have assumed a comma b as x 2 comma 1 plus y 1 comma 2, this was the linear mapping which we took. Now if you are putting all these values, so AB is equals to x is what? 2a minus b by 3. Y is, 2 comma 1 is also here. Plus y is what? 2b minus a by 3, 1 comma 2, right? So that means if you expand this value, because t is the linear mapping of this part, okay? So if you distribute t throughout, so what you will get, t comma ab, t is the linear mapping, remember? Question has given us. So 2a minus b by 3, then t of 2, 1 plus 2b minus a by 3, t of 1, 2. Now you remember, if you go further to question, you will see t comma 2, 1. Question has provided us the value of this as 5 comma 7. And for t comma 1, 2, the mapping is 3 comma 3. Okay. Now if you substitute and find out the values, so here t a comma b would be, now multiply this. So you will multiply this with 5 and then this with 7, right? So what you have got, first of all, 2a minus b with 5. So 10a minus 5b by 3, comma, if you multiply with 7, 7 to the 14a minus 7b by 3, right? Similarly, on to the other side, if you multiply this with 3, 3 to the 6b minus 3a by 3, then again with 3, 6b minus 3a by 3, right? So this is your, what we have got. So you can divide it also to simplify. Let me write it here. So now what we have got is, if you further simplify it, what you have got, so t a comma b is equals to, now see, this can be added, right? Why? Plus operation is there, and these two are the first corresponding parts, and these two can be added, right? So what you can write here, 10a minus 5b plus 6b minus 3a by 3, and here what you have got is, just bear with me, so what you have got is 14a minus 7b by 3 plus 3 is same, so LCM can be taken, 6b minus 3a, correct? So if you simplify it further, you will get 10a minus 3, 7a, 6b minus 5b plus b by 3, right? And then here you have got 14 minus 3, 11a, 7 minus 6 is minus b by 3, correct? So this is your a and b. Now what question has given us further on is that basically we have to find out the rank of the matrix A, right? Rank of the matrix A, which is corresponding to T. And now the further information which we can use to find out the value is that we have standard bases mentioned in the question. So standard bases are E1 and E2, and you know, basis is a reduced form of a matrix, right? So we can find out basis using row reduction. So standard basis, what do you think can be? 1 comma 0 and 0 comma 1. Okay, you need to remember that standard bases are these two. So that means if you put any of these values, I mean, you can find out a matrix using these. So let's say I'm considering A as 1 and B as 0 for first base, and A as 0 and B as 1 for second base. So my T1 comma 0 would be, so if I am putting A as 1 and B as 0. So if I put A as 1, 7 times 1 is 7 by 3, right? So 7 by 3 for what? 1 comma 0, correct? You can write it later on also. So what you have got, 7 by 3, and for this one, comma If you substitute A as 1, B as 0, so 11 by 3. Correct. So this is the value of T1 comma 0. That means 7 by 3 is for which base? So you can write it as this is for one base and another one for another base. Let's say for 0 comma 1, what you have got? If you substitute A as 0 and B as 1. So if you substitute A as 0, B is 1, so 1 by 3, A as 0, B as 1, so minus 1 by 3. Correct. So that means you have got 4 elements of a matrix. Your matrix A would be, for which you have to find out the rank, right? So that will become your A is, so first element 7 by 3, 11 by 3, okay, for single base, and then another 1 by 3 minus 1 by 3. This is your matrix. Now, can we find out the rank of this matrix? Because we can see that all the rows are non-zero numbers, are having non-zero elements. So that means rank should be 2. But before that, you need to check whether it is having determinant as 0 or non-zero. Because if it is 0, we cannot find out just like having, counting the numbers. So let's say A determinant, what would be the determinant? So you need to multiply these two, 7 by 3 multiply minus 1 by 3. Minus is in the formula. Then 1 by 3 and 11 by 3. So what you have got is, try to solve it. So you have got minus 7 by 9 minus 11 by 9. That means minus 18 by 9. That means minus 2, right? And minus 2 is not equal to 0. So the elements we can count directly. We don't need to reduce it further because all the elements are non-zero numbers. So rank of the matrix will be 2. So just for recapitulation, this is your answer. What you need to understand is what are bases, what is the rank of a matrix, what is linear mapping. This we have already discussed. Now, after understanding these three, you have to find out another matrix for which you need to find out rank. So, to get the elements of that matrix, you need to solve this linear mapping, okay, using standard basis. I hope you understand this topic, and if so, then don't forget to like, share, and subscribe my channel. Till my next video, take care of yourself. Bye bye.